Welcome. It is New Year's Day, 2022. So it's been a week since the 2021 Advent of Code event finished, and I did finish the last problem on the 25th. But I was falling behind at the end, and I definitely kind of limped over the finish line. I never got a chance to watch back my videos from day 22 on and to reflect on the code that I ended up writing for those things. And I think one of the big things you can get out of an event like this is a chance to reflect on your own programming. I really think it has value no matter how much experience you have. So today I'm just going to go back and look at days 22, 23, 24, and 25 and just do the thing I've done for all the previous days. Kind of how did I do? What mistakes did I make? How could that have gone better? What can I learn from the experience, right? For day 22, I thought I did fine on part one. I even thought I explained myself fairly well. But then I apologize for the live video for part two because it was just me flailing a lot. Actually, I have my reflections on the other screen. Let me bring it up so you can look at my reflections as well. And then I came up with this quite complicated approach where based on this whole thing that back in the day people used to do with bitmaps, where bitmaps were just a combination of regions and you'd keep the upper left corner and then there was an algorithm for intersecting regions in bitmaps and you just have a collection of inversion points. Anyway, I came up with this approach in 3 dimensions. If you're trying to intersect 2 cuboids, I realized that you can partition space into 27 distinct regions. And some of those 27 regions will be in one, some will be in the other, some will be in both, some will be in neither. And what's more, it's pretty straightforward to, first of all, finding the boundaries of those 27 regions is simple because there are just kind of 3 dividing lines in each dimension, right? So it's not like you need to, explicitly carve out all 27. But also figuring out which of the 2 cuboids each region is in can be done. Hey, quiet. Sorry. Can be done with logic. You don't need to think through the geometry of all that stuff. And that is kind of the best kind of programming, where you're not coming up with a whole bunch of special cases, but you have an algorithmic way for the computer to figure out all the special cases. I do like that approach. And the one thing that I never really got to is what you really want to do then is also have a way of remerging adjacent cuboids, which is just seeing whether they have the same boundaries in 1 or 2 dimensions. That's straightforward, but I never got around to even coding that at all. If you did that, then you would have a, optimal? I don't know if there's a unique optimal solution, but you'd have a really robust way of representing regions in space if you implemented that algorithm. So I do like that approach. And also, another thing you get from Advent of Code, you think about problem spaces that you don't very often, and I don't do much geometric programming at all. And as terrible a time as I had with day 22, you can see on all my reflections how devastating it was. I do think there's a lot of value in that because now, it's not like I'm an expert at geometric programming now, but at the very least, I think some of those first, how do you think about, moving through 3 dimensions and spaces and everything? I've done a little bit of that thinking, and that makes me a better person. So I'm glad I thought through this clever approach. But I mean, the one major, huge mistake I made in this, geometric problems in particular, anytime someone is asking you to consider a 2-dimensional, a 3-dimensional, or an n-dimensional problem, you start with one dimension, right? And you work up from there and you figure out your algorithm for the one-dimensional case, and then you generalize it to two. And in the process of generalizing to two dimensions, generally you see how to generalize the generalization to add any number of dimensions to it. In truth, as I think I demonstrated, merely visualizing 3 dimensions is really hard. And no one can really visualize 4 dimensions. There can be just some disagreement about that, but I've known some mathematicians who worked in doing a lot of 4-dimensional geometry, and they said picturing it is a fool's game. You should do the math. Anyway, and so I obviously should have started by thinking about a single dimension, and in the end, the solution that I came to was largely about find an optimization for a one-dimensional case and then just apply it 3 times. So that was very dumb, and that's a lesson that I really should internalize. And it's not just geometric problems. Almost all, real mathematics is about, take some problem that looks really complicated and find a simplification that you can fit in your head so you can come up with a clever thing to. And every time you see solutions to, these grand, complicated mathematical problems, it's generally because, the mathematician came up with a simplification that they could think about, even if they don't tell you what the simplification is because they want to look clever, right? Anyway. So, I think I mentioned this in one of my subsequent videos. There are 2 approaches to optimization, right? You can make deep use of knowledge of the problem domain. This is how it, get a better intuition for how geometry works, and cuboids, and regions, and space, and everything. And that's all great. Or you can write an implementation that's too slow, and look at that implementation, and figure out the bits that are too slow, and find optimizations for them, right? And very often when you do that, you end up at the same place, because optimizing this particular implementation will give you insight into the intuition behind, in this case, the geometry. And I do think that's the case here, because what I ended up with this kind of, range dictionary, run array, run compressed encoding, it ends up representing cuboids possibly in the same way that my 27-region approach with remerged regions would have come up with. I suspect those 2 representations look very, very similar at the end of the day. But anyway, I probably should have started with the second approach, knowing that I didn't have a good head for the geometry. Anyway, I built this this range dict data structure. Do I have it here? That was part 1. So part 2, the runlen was the one that I did. Yeah, let me make this big enough that you can join me in appreciating its beauty. So I made this range dictionary data structure. And it's interesting, I didn't implement any of the things that make you recognize it as a dictionary, but effectively it's a dictionary from integer to value. It's just that it internally compresses huge ranges of integers. Because it only says everything, this is just an array of everything above some value, above some integer, is associated with some value. And then, of course, the next higher integer, all the things above that are associated with some value. So it's only between this and the next integer that's actually associated with some value. So this is actually a dictionary. And what did I say in my reflections? Let's take this in order. I think this is a cool thing, and so I might flesh it out and add it to my silly little Advent of Code software library. But the thing I'm most proud of about this data structure is that it doesn't look like a dictionary, right? I don't even have index lookups. The whole thing, look up an integer and find its value. I didn't implement that. I only implemented the parts of this data structure that are relevant to solving the problem, which is really only this map range thing. How do you map a subset of the dictionary in the same way that you can apply a mapping to any old sequence in Swift? That's good. It's not just good programming for a programming contest. It's good engineering in general to identify the parts that are actually going to be used. Because I don't really care how great your unit test coverage. If you have a library with a huge number of functions that are never actually hit in production, I don't think you really know what you're doing, right? Yeah, so I think it's very good that I only implemented the bits that are actually of value to me. I'm proud of that. What else did I say? Yeah, okay. This is another case. Watching several days in a row, I realize this is a running theme. Tuples in Swift are half-assed, super half-assed. I'm not following the language evolution of Swift. I have heard whispers that they are talking about how do we make tuples conform to protocol. So they know this is a bit of a pain, but like the huge gulf between a tuple and a struct that just has named fields in there, in terms of functionality, is just so huge because you can just declare that, well, this struct, it's hashable, it's equatable, it's all these things, and like it's just so frustrating that tuples don't already do that. But Swift is a new language. I do believe they'll get to it. But the fact that tuples exist, like if tuples didn't exist, I could get away with writing structs, but because tuples exist, I'm so tempted to use them all the time. But I guess tuples were put in there largely as the convenience for functions that just want to return things and you don't do anything clever with them. But even so, it's frustrating. Anyway, in Swift also, there doesn't seem to be a protocol equivalent for, in C++, there's this concept, which actually concepts are a whole thing in modern C++, and I'm not even familiar with that because that's quite recent. But there is this concept in C++ of something that is just default constructible, and that's, you can just, in Swift, you can initialize it with no parameters, would be how you do it in Swift. There doesn't seem to be a protocol for doing that in Swift. I think there is a way to write a generic that requires not protocol conformance, but some function. I think maybe, but that's an area of generics that I don't know much about, and maybe I should write myself an action item to, yeah, okay. Let's tell myself more generics. So there might be a way to get this to work, to, have, because effectively what I want to say is I want an initializer that takes no arguments if it just so happens that you can build a T with no arguments. And Swift has very nice functions for saying if the parameter you're generic on, if the type that you're using in your generic conforms to some protocol, then your generic thing can conform to some protocol or adds all these functions and everything. So you can add little bits to these data structures piecemeal, and that's a great feature. But I don't know how to do that if the feature you're looking for isn't named by a protocol. So anyway, that's a bit of a shame about Swift. In several places in this code, like, this whole range dict thing. So I didn't even really document it, but this array here of these things, it should be in sorted order by P. Nothing else works here if they're not in sorted order. I probably should have come up with some assert invariance function just, because that is a way to hand wave at something like that. But then it's in sorted order, and in several places, like I do this kind of linear scan of all those things. Everywhere I do this linear scan, it really could be a binary search. But I don't know of a binary search library in Swift for sequences that happen to be in sorted order. So that is probably something that I could add to, my own little Swift library, because it didn't really come up in this year's Advent of Code, but binary search is definitely a fundamental enough algorithm that Advent of Code expecting you to have it available or at least be able to implement it yourself is perfectly reasonable, right? So I know I could have used binary search, but I don't believe there is a binary search in the Swift standard library. And then, of course, I just, like, the whole thing about this range dict, it's all I mean, literally, it's all boundary conditions. All of the logic is about what happens when I hit individual boundaries. And, like, a huge amount of real programming is just coping with boundary conditions. That's just an observation about what goes into engineering in general. So, sorry, the dog is playing with her toy, so that's that noise. I kind of fussed a lot about, I had this function that took because it was a transform that took a thing and I just wanted to return a constant. The way to, and I made it a multi-statement thing, and I, let underscore equal the parameter that I want to ignore. The correct way to do it is this, and actually I was just playing with this as I was watching the video over here. I don't know if you can read my shell. But the point is, if you have a function that takes, another function, this is how you do it. And the thing I was testing here is you can use multiple underscores to ignore multiple parameters in there. And I'm a little curious how they implement that in Swift, because that is a special case. It's not just that the compiler knows, I don't need to warn about this thing, but it also knows that normally if you were to name multiple parameters with the same name, I think that would be an error. But it knows underscores are special, so it's not even about suppressing warnings. It's about it's not a syntax error anymore if you're using underscore. Anyway, I found that vaguely interesting, and that's something I should know about the language, and I think I vaguely did, but in the heat of the moment, you're not always thinking straight. And I spent... Bailey, can you stop with the toy? Bailey! Enough. Okay. I spent a long time debugging just this one off by one error in... where was it? In my actual implementation here. These pluses, I had made minuses just because, my brain was, did the wrong thing. I took a long time debugging that off by one error. That's just, is there anything more to say about that? Oh, yes, that's why it struck me as interesting, because when you're doing real engineering and you have a real unit test suite, there's actually value in hitting every off by one error, because then, your unit tests catch it every time. So getting your code wrong the first time can be an asset, or at least off by one error wrong. If you have a programmer whose designs and algorithms are terrific, but who always have off by one errors, modern programming practice means they'll write more robust code than other people. But it does hurt you a lot in programming contests where you just have to get everything right the first time. And also, my debugging of that off by one error was terrible. I should have started by just logging my inputs, because it was totally obvious once I was, it was obvious from the parameters that I was continually adding these empty ranges, right? So just one look at the parameters would have demonstrated what was going on. I also could have asserted preconditions on my parameters that you're not allowed to have end before start. And that's also arguable how great programming practice that is. There are a couple of schools of thought, but that's something that definitely would have caught it faster. And I wasted a lot of time debugging an error that I could have caught in a lot of ways. So that was quite poor debugging strategy. So that's my thought on day 22. I spent almost 20 minutes, but I had the most thoughts about that. The others, not nearly so interesting to reflect on. So what was day 23? Let's try and remember. 23 was... Oh yeah, this was little things moving around, and I took 2 or 3. I took a couple of bites at this, didn't I? This was the one I was almost falling asleep. You can literally see my eyes start to close doing the videos. And so the big thing is giving a problem a read when you're tired is fine. But a generally novel problem for me at least, when I'm very tired, my focus really narrows. And so I can see myself, I found one way to, and I just focused in on the details and the details and the details. And what this problem took was taking a step back and realizing what was really going on in there, right? I did, I think I did add this at the time, but I should add unit tests and everything. My grid interface didn't have a setter. A setter for the subscript operator, and I should do that. In hindsight, like, the code for this was quite ugly. So let's go to day 23's code, right? And let's make it big. So the code for this was really quite ugly, and a lot of, clever logic going on and everything. A smarter thing to do might have been to actually translate all this, not into moving to particular coordinates, but just saying, here are the starting positions, here are the possible haul things, here is how people block each other. It might have ended up as cleaner code if I had just translated it to a better representation. A lot of things in engineering are about the choice of representation has a huge effect on how elegant your code looks. And I didn't think very hard about the representation here, even after I had realized a better structure for the problem. So that's something to remember. Tuples. They're not very good. This was another case, because I used it here so I could do my memoization, didn't I? Where did I memoize? Here. My explored thing. I'll probably mention this in my overall Advent of Code wrap up, but memoization is one of the few big optimization techniques that you're expected to know when you do Advent of Code, or at least it's one of the only clever optimization techniques that I have ever used in Advent of Code. I think I mentioned either here or in the next day, branch and bound is a whole other way of thinking about it. None of that cleverness has ever been of value in Advent of Code. Memoization has. So, okay. Oh, I had this question while I was making the video. Why are there insoluble states? Because it seems like, eventually, no matter what, things can just move. But I had made this restriction where you can only move to a position in the hallway once, and then you wait to move to your final destination. And that restriction makes a whole bunch of positions insoluble, because you can just, get your amphipods, arrayed out there to block everyone. And then if you have two blocking each other, you're screwed. So that's why there are insoluble states. Unsolvable, insoluble. Insoluble sounds better, doesn't it? Anyway. Also, I did catch my main problem here with an assertion. Right here, I guess. That was an assertion at one point, and then I kind of ignored it. But the assertion did catch the underlying problem that I was looking for. I just didn't really listen to what was going on. But I'm a big fan of assertions. I'm particularly a fan of assertions for this kind of programming, where it's all about getting it to run once. There, again, are two schools of thought about whether assertions in production code are contentious, because what happens when one fires in production, right? Just having your whole system, crash and burn because some invariant, didn't happen to be the case is truly worrying. And so maybe they should throw exceptions or something, or maybe you just turn them off in production code, but then people assume that the assertion is true, and that's how you can get security issues and so forth if people are relying on the assertions, but it turns out that you actually get logic that falls through the assertion because they're turned off. So in production code, it's very much a mixed bag. When you're just trying to hack something out because you're trying to solve a specific problem for right now and you just want the code to run, assertions are very good practice. And as you've seen over these 25 days, I do tend to write a fair number of assertions. Not nearly as many as I could, but when I'm not quite sure what's going on, I'll often add assertions. Okay, So that's all I had to say about day 23, which was moderately straightforward, not terribly interesting. Bailey, hey, stop it. Okay. Okay, day 24, I made 3 different videos, didn't I? And my approach changed every time, which I think says something about, like, I'm going to throw you out of the room if you don't stop doing that. Bailey, 1 second. I'm throwing you out of the room. Okay, so, and it's, well, I was just saying, time, even when you're not actively thinking about a problem, can be really useful. Because particularly every time you come back to the computer, you're forced to kind of rethink and page everything back in, and it causes you to think through the big picture again. Because very often when you're at the keyboard, you get mired in the details and can't step back. So stepping away from the machine is often useful. This one particularly, because this is the one we had this assembly code, right? Yeah. We had these instructions, and effectively we wanted to come up with, what was my puzzle? Bailey! See, now she's barking because she's lonely. We had all this assembly code, and we had to come up with inputs that would produce an output of 0. That was what this problem was about. And Bailey! Okay, let me let her back in, but without the toy. Then she won't make the noises. Okay, girl. Come on. Okay. Now she'll just hassle me because she has no toy to play with. Okay. Right, so at some point, because I was trying to understand this code, so I got into the thing of, well, let me try simulating it and thinking how it works. And this is, again, another example, particularly when you're tired. You get caught up in a particular task, and you keep executing that task and kind of forget what the original intent of doing the task was. And in this case, I really should have pulled back and thought, what is the structure of this code? And I was simulating it, and I got quite far in simulating it and kind of completely lost. No, I really should have looked at the structure, because the repeated stanzas, we had 14 repeated stanzas. Identifying that is actually the most, I think, was the most important part of this problem, was identifying the stanza structure here. Because all of there are a million optimizations that you can apply once you realize there's a stanza structure. Also, once I realized there was a stanza structure, I compared, and because for each of the 14 iterations of the stanza, there were 3 constants that changed. And I went through and twice, there's like 10 minutes each time of me going through each and copying down the 3 constants. I could have used command line tools, or I could have used a huge number of different tools to pull out those constants. I even probably could have written some Swift code to pull out the constants fairly quickly. But if I had just, copied the one stanza, and, replaced the constants with something completely arbitrary, and then catted it to itself 14 times, and then diffed that against the original program, that diff output would have told me only the lines that changed, and those are only the constants, which is pretty straightforward. And whether I copied that into an array by hand, or whether I wrote some clever cut operation on the command line, or just used BB edits, because I know how to do columnar editing now. But any of those things would have been substantially faster and much more accurate than my own, doing these 14 things by hand. 14 is exactly that number that is a bit much to be doing by hand, but not too much, so it's hard to decide. But in this case, there are certainly, I do think, catting a stanza 14 times and then doing a diff would probably have been the best way to do it. I iterated on several overpowered solutions. I really like my overpowered solutions. They were thought-provoking. I enjoyed thinking about, what if I just computed algebraic expressions at each stage? of this operation so that at the end I could solve, and set z equal to 0 and come up with solutions to this system of algebraic equations. That's clever and interesting. There are a lot of problems in real life where that's a great approach, but it's way overpowered for this. Eric is never going to ask us to solve complicated systems of linear equations or something like that. That's just not what Advent of Code is about. So again, I should have exploited knowing this conceit of Advent of Code that everything is soluble without using fancy data structures or algorithms or machinery, right? I spent a long time after I'd done this translation. I then went and I said, well, can I write a reverse function? And actually, it's interesting, when I came back to the machine the second time, I said, oh, no, you can't do it. But I had actually built machinery such that you could do this reverse function because you can have a huge number of possibilities. It would just have a large branching factor. But my thought was that you could prune in both directions, and that would be the way that you do it. But it turns out that reverse function is completely unnecessary. There's a very straightforward optimization. Once you know the stanza structure, all you have to do is recognize that the only thing carried over from one stanza to the next is this z value, and there's a very limited range of z values. And actually, in hindsight, to skip all the way to the end, it's pretty obvious, even if my initial implementation, we'd had a huge branch of the number of z values that we could have spit out, we could have bounded that because we know we're only looking for z to be 0 at the end, and we're dividing by 26 in the last few stages, and that's the only way to get z back down to a low value. So you can obviously bound that by at most like a factor of 26, 26 to the 4th or something like that, 10 stages from the end. So even if we'd gotten to a big number by stage 9 or 10, we could have, trapped that back down. So again, all these things are obvious in hindsight, but I could have realized that all my clever machinery wasn't necessary if I had really thought through the structure of the problem I was addressing, right? Because it turns out the only thing I really needed to do was some kind of quasi-memoization on the z value, which is the only thing passed from one iteration to the next, right? I could have, instead of hand translating this thing, writing an interpreter for the code for for each stanza would have been fine, but you still kind of need to identify the stanza structure so you know how z is passed from one stanza to the next. So doing a hand translation probably is the most efficient way to do it. Anyway, 24 I really feel very silly about because, I suppose this is true for most Advent of Code, but well, no, it's not. Most Advent of Code problems, at least up to the last week this year, I am very happy with the approach that I chose, immediately, in most cases. And it's just that I'm quite slow at implementing these things by programming contest standards. In this case, it took me a really long time in multiple iterations to come up with the right approach, which is unusual for me. Except for these last, 5 days or whatever. Implementing that approach was actually quite straightforward and quick. So I was slow at the thing I'm usually fast at on day 24. And that's, a little humility is called for on that front. So day 25, let's give us a little space. Day 25 was this kind of cellular automata type thing. We just had these little arrows that were moving around in their way. What's the simpler approach? Yeah, we had these arrows that were kind of creeping to the right and to the left, arranged on a torus. The big thing to say about day 25, there was no trick here. Day 25 is very often fairly straightforward. There's no crux to it. There's no complicated thing. You just have to implement the thing. And these are the ones that I, unless they're very complicated, I usually am not competitive at. And I was particularly bad at implementing this one. So it's worth reflecting on just why I did so terribly at implementing day 25, even though it was completely obvious I was going to get to the finish line on this one because there was no trick to it. Part of it was I was rushing. I knew from the start that this was 10-15 minute problem, right? And when you put that kind of pressure on yourself, sometimes, if it all goes well, that haste will get you to the finish line, but sometimes it can also, the haste can cause problems that make you go slower in total. It's a high variance strategy, right? And I definitely think that happened here. You can see me flubbing and not thinking and just kind of flailing a little bit on the code. Most particularly, clever hacks. Anytime that you think, ooh, that's clever, I'm doing something not a lot of people would have thought of, that is an indication that you're doing something wrong and that you're a lousy programmer. Good programmers, if you look, the best engineers that I have worked with in my career, you look at your code and you never think it's clever. The overall design is just very well thought out, so well thought out that no particular line of code has anything that jumps out at you as being really smart, because the structure, the representation chosen, the overall design and architecture makes all the code flow naturally one to the other. And when you have code that has a huge amount of very picky special cases, it's great to have programmers that can actually get code with a huge number of special cases and everything to work, because that is the life of a software engineer. Very often that's an indicator that they're not great at kind of the big picture, the things that really make a difference to engineering productivity, right? And that was definitely the case here. There's just one specific thing. I did a lot of little clever hacks. This whole thing about I used a special, where can I, come on, on day 25, right? I initially did this special thing where, the right parenthesis was a temporary marker that something was gonna go there and would be changed on a second special pass. And that's all. Oh, sorry, this is too small for you to read. So I had all this. I had a whole bunch of all this cleverness in here. And the reason I needed this cleverness is I was using this pattern, which, gets used a lot, is I was building the next grid incrementally by building a line and then appending to the line and then appending it to the grid. And that is the most efficient way. Well, not entirely, because Swift is very good at copy on write stuff. But that, in theory, you can see that is very efficient, right? If I had just said, just make a copy of the grid and just change the things in that copy that need to be moved. If I had just done that right from the start, almost all of this code would have disappeared. I mean, I think it would have been half this length. The amount of code, almost no special case, it just all worked. And just that one oversight that, I'll use this pattern of building things incrementally. There are so many of these stupid hacks. Just watch the video. It's all of my programming is hacks to get around the fact that I can't just change a pre-existing grid. I could have just built a pre-existing grid and changed it. So it's a classic example of clever programmers being bad programmers, and that's what I was on day 25. I was clever and not good. So what else did I say about day 25? Yes. The one other thing is my library. I had previously added a subscript setter to my grid functions, but I have a subscript. I have an integer-based string subscripting operation that I added to my library, but I don't think I have a setter in there, and that also caused me to translate everything to arrays of characters as opposed to arrays of strings, which, whatever. I mean, it's not a huge deal, but I should probably add that to my library. So, those are my comments on the last 4 days of Advent of Code and my quite mediocre performances at all of them. But again, when you're not doing very well, that's the best time to reflect, because you obviously have some things to learn. But the biggest thing I had to learn, I was just very tired and the schedule wasn't working for me in the last week of Advent of Code. But anyway, I will make one more video reflecting on the overall event and my experience. partly doing Advent of Code, and for the first time having this kind of reusable library that has some utilities in it, but also my experience of making these videos, which, as I mentioned before, in the 2021 event, this was my big new thing, was trying to record myself doing the problems, and that has been quite educational, if not terribly entertaining. So, anyway, expect one more video in this playlist in the next day or two.